Okay, so today we're going to talk about tangent and secant lines, and more specifically how they relate to some of the angles they make and stuff like that. First of all, we've already talked about tangent lines. A tangent line is a line that intersects a circle at exactly one point and one point only. Okay, so if I have a circle, a tangent line would be something that comes off like that. It just hits at one point, technically, like right there. If I drew a better circle, that'd be more obvious. So like that would be like a pair of tangent lines, like right there. They each have like one intersection point. A secant line is going to be a line that basically intersects the circle twice. So it hits the edge of the circle twice. Okay? And there's going to be some properties that we talk about as far as how this works with our different circles. So there are four theorems that we need to talk about to start off with. The first of all is when we have two tangent lines, how this angle right here, so we have two tangent lines that form an angle off the circle right there. That angle is going to equal 1/2 of the far arc. So there's two arcs here, right? There's this initial arc, and then there's this major arc. So it's going to be 1/2 of this major arc minus this minor arc right here. So if we wanted to see the formula for this circle, it would be right here. The angle BAC would equal 1/2 of the major arc BDC minus the minor arc BC. Same idea if one of them is a secant line. So if we have a secant line, or if they were both secant lines, it's still going to be the far arc minus the near arc. Okay, so if they were both secant lines, we'd have the far arc minus this near arc. But this is a secant and a tangent. So again, the far arc here would be the CED. So we're not including this because this isn't part of what's been intercepted by the secant line. Just over here. And then this would be the near arc BC. Okay, and I'll go through a couple examples of those in a second. The other property we need to talk about is when we have a tangent line and a chord that's intersecting. So not a radius. A radius intersects at 90 degrees. This is a chord. Basically what happens here is the intercepted arc, so BD, is going to have the same properties as like, what's the word? Oh, I can't think of the word. The inscribed angle. So that means that basically whatever this measurement is, this arc is going to be twice the length. So CBD, that angle is equal to 1/2 of that arc, or if we're looking at the arc, that angle would be equal to twice, or that arc would be equal to twice of that angle right there. Right? So remember, when it was an inscribed angle, the arc was twice the size. Same idea here if it's a chord and a tangent line. Okay, and the last thing we need to talk about are intercepting chords. So if we have intercepting chords, we basically have a pair of vertical angles, right? This angle is going to equal that angle is going to equal that angle. There is a property with the arcs. So the opposite arcs of the vertical angles are going to equal this interior angle in a specific way. If we take these two arcs, add them together and half it, it would equal this inside angle. Okay? So let's do a couple of examples just to make sure we got it. So looking here, I'm going to zoom in a little bit so we can see a little bit better all these numbers. Okay. So on this problem, we're given that outside angle, and then we're given the two arcs right here. So basically, if I want to figure out this question mark, I don't know what either of these are, right? But I know that together, they would make up the entire circle. So they would add up to 360. So that means if this is question mark, this would be question mark minus 360. So the angle, 75, has to equal 1/2 of the major arc. Well, I'm going to write that as dividing by 2. So all over 2, the major arc, which is question mark minus 360 minus the question mark, right? That's the far arc minus the near arc. Okay, well, first thing I'm going to do to solve this is I'm going to multiply by 2. It's going to multiply each side by 2. It's going to give me 150 is equal to question mark minus 360. Or sorry, I wrote that backwards. It's 360 minus question mark. 360 minus question mark. 360 minus question mark. Minus question mark. Okay. That's going to make more sense. 360 minus question mark minus question mark. Okay, well, I can combine those two question marks, and it's going to be 360 minus 2 question mark. And then I could minus the 360 to the other side, so 360 minus, or sorry, 150 minus 360 is negative 210. So minus 360, and I'm going to get negative 210 is equal to negative 2 question mark. And then I would divide each side by negative 2. Divide by negative 2. And we're going to get 105 is equal to the question mark. And that's my answer. This side would be 105. If I took that away from 360, I would get 255 for the rest. But that's not what it asks. It just wants to know what the question mark is. So that's one answer. Okay. Next, I'm going to do an example of a tangent and a chord. So again, the property here is it's just like an inscribed angle. This intercepted arc, so ED, is going to equal twice of this angle. So basically, I would just multiply by that 2, and that would be what that question mark is. So 70 times 2 is 140 degrees. And that would be my answer. Okay, then let's do one of these that has a secant. So this one right here. Were you able to even see what I did there? Sorry, this is what I was talking about. I don't know if I was actually under the camera when I did that, because I wasn't looking at the screen. But that would be 70, so I would times that by 2 to equal the question mark. Okay. And then secant is something like this, right? This is a secant line. It's the same property as up here, right? Far arc minus the near arc. Okay, so I want to know what the near arc is. I know the angle is 38 degrees. So the angle is equal to 1/2 of the far arc minus the near arc. So it's going to be the far arc is 167 minus the question mark, all divided by 2. So first thing I'm going to do is I'm going to times each side by 2 to get rid of that. And I'm going to get 76 is equal to 167 minus question mark. Then I'd minus the 167. 76 minus 167 is negative 91 equals negative question mark. I get rid of the negative by dividing, and that intercepted arc, the near arc, is going to be 91 degrees. Okay, and then I'll do one more example, you guys. Example of the intersecting chords. So remember, the property here is the angle is equal to 1/2 of the two arcs added together. So my angle is 117, so 117 equals 60 plus the question mark divided by 2. First thing I'm going to do is I'm going to times everything by 2, which would give me 234 is equal to 60 plus the question mark. Then I would minus the 60. Okay, so 234 minus 60, and I'm going to get 174 is what the question mark is equal to. So this outside arc, ML, which again looks like most of the circle, is 174 degrees. And that is how you do all these different properties.